all about natural gas analysis according to ASTM D1945. What is natural gas? Natural gas is a naturally generated gaseous mixture, consists of methane, other hydrocarbons, and permanent gases like hydrogen, oxygen, nitrogen, as well as carbon dioxide. According to ASTM D1945, it's required that the system configure with multiple columns, detectors, and switching valve system for the analysis of natural gas. Our natural gas analyzer is configured with 3 inlets, 3 detectors, 5 columns, and 4 valves. It is very critical to accurately set and control the valve switching time in order to determine complex natural gas, because natural gas is evaluated depending on its chemical composition and concentration. Let's figure out how to set the right time to switch the valve. At the initial state, all valves are off position, while each of the 3 sample loops is being filled with gas sample. Turn the valve 1 to on position 0.1 minutes after the analysis run starts to transfer the sample loaded in the sample loop 1 to Poripat Q column, and then MolSiv 5A column to be detected by TCD. In the sample loop 3, the sample is transferred to Poripat Q column connected with valve 3. Hydrocarbons and carbon dioxide with longer retention times than others are retained in Poripat Q column, while the permanent gases such as helium, hydrogen, oxygen, nitrogen, methane, and carbon monoxide are co-eluted in advance. And then, the permanent gases, except for carbon dioxide, move to MolSiv 5A column in valve 4. Among them, helium and hydrogen are detected earlier in TCD2, and the rest of the others are retained in MolSiv 5A column. After hydrogen and helium completely eluted from the MolSiv column of valve 1, turn the valve 1 to off position to vent the carbon dioxide and hydrocarbon groups retained in Poripat Q column not to be transferred to MolSiv 5A column. In the meantime, oxygen, nitrogen, methane, and carbon monoxide are being separated in MolSiv 5A column in valve 4. It's important to isolate MolSiv 5A column from the flow path by turning on the valve 4 right after the elution of hydrogen so that oxygen, nitrogen, methane, and carbon monoxide are being trapped in MolSiv 5A column. If the valve position is switched after elution of carbon monoxide from MolSiv 5A column, it'll be too late, because carbon dioxide and some of hydrocarbons would already be absorbed in MolSiv 5A column. While trapping those compounds in MolSiv 5A column, carbon dioxide, ethylene, ethane are eluted from Poripat Q column and detected by TCD2. It requires higher oven temperature to elute hydrocarbons from Poripat Q column, but this might also cause co-elution of oxygen, nitrogen, methane, and carbon monoxide in MolSiv 5A column connected to valve 4. So, acetylene and hydrogen sulfide need to be backflushed by turning on valve 3 at the relatively low temperature. After that, turn the valve 4 to off position to separate oxygen, nitrogen, methane, and carbon monoxide in MolSiv 5A column and to be detected by TCD. Next up is how to set the method for natural gas analysis and its reliable data results. We used GasPro column for capillary inlet and MolSiv 5A and Poripat Q column for each of 2 packed column. For helium detection in TCD1, which is connected to inlet 3, we used argon as a carrier gas here. After the analysis is done, you'll get these chromatograms. You can get increased sensitivity in hydrocarbons from FID compared to TCD. This is our natural gas analyzer, Chromatogram ASTM D1945 Player. It shows superior sensitivity, effective determination of gaseous compounds, better resolution, excellent repeatability, improved productivity. Also, our Chromatogram ASTM D1945 Player provides plug-and-play solution with smart hardware platform, ease of use, optimized method setup, and intuitive software control. Crowzen ASTM D1945 Player. Fast and reliable natural gas analysis with accuracy and precision. Need more detailed information? Visit our website